Okay, in this first question, we're going to look at allotropes of carbon. Specifically for this one, we're going to look at the diamond structure. Remember, diamond is a giant macromolecule whereby we have a central carbon atom surrounded by 4 other carbon atoms in a 3-dimensional shape. Each of these covalent bonds being a pair of electrons, meaning that all 8 electrons around the central carbon are involved in bonding, and subsequently none of them are free to move, which allows us to then explain why diamond itself doesn't conduct electricity. Remember, in graphite, one of those electrons is delocalized and so can do. In regards to the structure and more physical properties of diamond, then, the presence of the 4 covalent bonds, makes it have a high melting point. But the key word to look at, obviously, for exam technique is the word strong. The fact that the bonds are strong means that it has a high melting point because it requires a lot of energy to break, and subsequently because, again, lots of 3-dimensional structure, lattice arrangement, it makes that substance really hard. Looking then to different allotropes of carbon, obviously the first one being diamond, the second, third, and fourth structures are different to diamond in the sense that these carbon in the central carbon atoms are only surrounded by 3 this time, and so these ones are based more around the graphite structure. A being a singular layer of graphite, and so more correctly known as graphene in that sense. B is a very specific structure. It's commonly a C60 molecule, so 60 carbon atoms into a singular entity. It's got a common name of essentially just called a buckyball. Its full name being Buckminster fullerene, part of the fullerene family. Likewise, C is also part of the fullerene kind of family, but the structure of this is more tube-like. And essentially, if you imagine a singular sheet of graphene taken and ultimately just rolled into a tube shape, what you get is a new area of science called carbon nanotubes, nanotechnology, and things like that, which we'll look at in more detail later. But carbon nanotubes do literally exactly what they say on the tin. They are tubes which are hollow down the middle. And some of the potential uses of these allow us to deliver things in a similar way to a hose pipe delivers water. We could use carbon nanotubes to deliver drugs into the body and things like that. The strength of the graphite itself, the fact that it's hard, means that we can use these as strengthening within structures. And then obviously that's answering question C at the same time, in the sense that we can use these for drug delivery systems into the body. And also strengthening of materials in a similar type of way. If you think of reinforced concrete, just got pieces of metal through the middle of it, this can reinforce things like hockey sticks, tennis rackets, and things like that. Sometimes when you see carbon reinforced, that's what you're looking at.